So in the node editor, we can build up some node-based interesting networks that can do things that would be difficult to do by hand. So I'm just going to create a fractal. Remember we looked at fractal earlier and I said it could be animated. And it can be animated not just to be used in a texture, but you can use the information in a fractal to drive something like the rotation of this thing. So let's look at this fractal for a second. And I don't know if I'm going to get this working perfectly, but I just wanted to experiment a little bit. So the fractal has got black and white values over the surface. And Maya can sample over this surface, looking across it as it changes over time, and use that to drive something like rotation. So if it samples this black spot, there'll be 0 rotation. If it samples a white spot, there will be some rotation. And we can change the quality of the map by changing the threshold and the amplitude and the scale and all that sort of stuff. So we can turn on animate here. So let's just do something simple. We'll connect the out alpha. So alpha in this case is not transparency, but is black to white values. So it's a single channel attribute. So because it's a single channel attribute, just black to white, I can't connect it to rotate x, y, z. I can only connect it to x, y, or z. So if I click on the ligand rotate, go to rotate x, you see it pops in this thing. It's a unit conversion because rotates in degrees. And this is just in 0 to 1 values, so it's going to put this in between. And so let's animate the fractal so we can see the change over time. So when you want to animate the fractal, you have to turn on animated, and then you can set keys on time here. So we'll do set key, or you could put an expression in there, I suppose. So I've changed the time, and then I'll just change this to 1. It's probably going to be too fast. So let's look in here. Let's look a little closer. I'm going to get rid of that other animation actually for now because I don't want to have to keep following this thing around. So I'm just going to break the connection. Oops. So let's look at this up close. So you can see it's kind of jittering around there a little bit. So that fractal is driving its rotation, but it's not jittering very much. So let's start working on making that better. So we can change that in the fractal itself. So we can change what black and white mean right now. They just mean 0 and 1. But if we go into color balance, alpha gain is a multiplier of alpha, so the black to white value. So if I change this to 20, when now we play the animation, you can see it's jittering more, right? If we change this to 360, then we can do something like that. So it's pretty jittery though. So we've controlled the degree of rotation, and now we can look at controlling the speed of the rotation. So we can change that in a couple of ways, and I'm not sure if I'm going to be able to get anything satisfactory here, but we can try. So right now we've got time keyed from 0 to 1 over 120 frames. I'm going to change this from 0 to 0.001. So it's a very small value. I'm also going to make sure I'm on play every frame here, or I mean on real time. Okay, so now you can see we've got more controlled rotation here. So we're controlling the speed by changing the speed with which this fractal changes. and then we're controlling the amount by changing the alpha gain here. Now, one thing you want to do whenever you do something like this with alpha gain, so think about what's happening here. It's going from black, which is 0, right? And so if you multiply 0 by 360, 0. Yeah. So it can go now from 0 to 360, but it's not going negative, so it can't rotate backwards at all. So if you want to fix that, you can just, this alpha offset, so offset is plus minus, gain is multiplication. So if our alpha gain is 360, we'll want to offset that by negative 180, so negative half the value. And then it should be able to, we're not going to be able to really tell here, but it should be, I'm going to turn that speed up, that's way too slow. So it should be able to go positive and negative now. So if we wanted to automate this, we could write a little expression in here. So if I can just right click on alpha offset, and I'll create a new expression. I'll just say, let's copy this name. Alpha offset equals that other one, which is, what's that called? Alpha gain. Not canon, alpha gain, times negative 0.5. So now, if I change alpha gain to 200, that'll change to negative 100. If I change it to 3600, we'll get negative 1800. Just leave it at 360. Okay, does that make sense? So let's look at other ways we can control something like this. So now we're getting a nice kind of jittery motion here. So another node that we could use instead of using the alpha gain, although that's a good way to do it, I just want to show you a different node. I can use something like multiply divide. And if you want to find all of these nodes, actually I can't remember where are they. Create node. Well, you can find them all in the hypershade. So if you look in the hypershade under, where is it? If you have the create node thing on. So this is where we're doing all our shader work. But under utilities, you can find all these things. So like there's plus minus average, multiply divide. So all these little mathematical things you can do. You can remap colors, you can reverse a value, you can do all sorts of things. But the one we're using now, and actually before we had the node editor, we used the hypergraph for doing all these connections between things. But we can use multiply divide to connect these things. So I'm just going to break my connection here and redo this. I'm going to get rid of that expression too. It's going to put things back to normal. So if I want to pipe a value like alpha, out alpha, into the ligand rotate, but control the way, the degree in which it'll rotate, instead of going straight in there, we can go into a multiply divide node and connect this to input 1 x. And we'll look at the node here in a sec so you can see what it is. So the multiply divide node has x, y, and z columns. So we just input the value from the fractal into input 1 x here. And we're asking it to multiply this value by this value. So you can do divide or power. We're just going to leave it on multiply. So if we want to turn this up, we can turn this up by 100. So it's going to multiply this value that it's getting from the fractal, move the decimal point over 2 spots. We get 39.6 for this. And then if we want to take the result of this out, we have to take out x rather than out y or out z, or output x. So if we go to output x, and then pipe this into the rotate, and we'll just use x because it's the same name, it's easy to remember. So now we've got that, and it puts the unit conversion in for us. And let's say we want to connect we want to bring out alpha again from the fractal into the multiply divide into input y this time. So now it's going into here, so you can see the same value is being put in here. But we can multiply this by something different. Let's say 20. And then we can take output y from the multiply divide and pipe this into rotate y. So rotate y will act a little differently than rotate x now. So you can layer the animation this way too. You can have these things acting slightly differently. So let's look at our animation. So you can see that it's rotating. It's on an angle now because it's doing both. So what can you imagine what the problem with this would be?
Using the same fractal for everything.
Exactly, right? So you're getting the exact same value for x and y rotate now. Even though I'm multiplying them by a different amount, you can see the rotation is at a different degree, but it's exactly the same, so you'll get very similar rotation. So instead, it might be better to actually just make a new fractal. And just change the quality of this fractal by, changing its amplitude and its threshold. So if I reduce the amplitude, we'll get sort of a grayer image. So it's blending between these. Threshold will give go all the way here and just get pure white. You can change the level min and level maximum of what white and black mean here. You can inflect it. That means it's being reversed. And you can animate it at a different speed too. So this one's been changed a bit. So I'll just animate it, set a key on time, then at frame 120, I'll change this one to 0.03. So it's a little bit more than the last one. I'm going to get rid of this multiply divide now. There are always a million ways to do anything in Maya. So I'm going to connect alpha out of my first fractal into rotate x of my ligand thing. And then fractal 2, I'm going to connect alpha out, or out alpha to rotate y. So now they're sampling different ones. And my alpha gain, I took off that multiply divide, so my alpha gain is very low. So I'm going to turn that up in both. So 20 in this one, I'll make this -10 for alpha offset. And then in this one, I'll give it alpha gain of 30 and -15 in the alpha offset. So we're just getting this kind of random animation now. So it's still quite low, multiplying by 20 and 30. But because we put this on its own So this is all happening on this level here, the ligand rotate. And in fact, you might want to, you don't want to ever translate this one. So I can just select these values in the channel box and right click and say lock and hide selected so I don't accidentally move those. Do the same thing with scale, lock and hide selected. So now if I want to animate it moving, maybe I shouldn't call this ligand translate, I should call it ligand transform, because I can use this to rotate the thing globally. But those little shaky animations are separated out. So I just set keys here on the parent level. So now we've got something simple like this. So it's kind of hard to see that animation, so I'm just going to go in and change those fractals to be a little bit stronger. So I'll just turn the alpha gain up to 300 and then negative 150 for the alpha offset. This one I'll change it to 200 and negative 100 for the alpha offset. So if I were blocking in the animation, I could block in the parent level movement, and then I could work on doing the rotation later on. So the trouble is if you try and combine the two, if you have to edit the lower level shakiness, then it means you have to edit the movement at the same time. Or if the rotation of the overall thing has to sweep down like this, you have all that shaky animation in the same channels, then it's impossible to edit. And it also means that you can use constraints to animate the movement of this as long as you put the constraints on the upper level, on the parent level, to move this around. So this is a non-dynamic solution to make something look like it has random motion. Does that make sense? Yes? Okay. Just going to save this scene. Just wanted to show you a couple other things. Just give me, can we go till like another 10 minutes and we'll break for lunch? All right. Let me just put this in the right spot. In April's animation, she's got particles coming together in After Effects to form a face in some of her neurons. And there are ways we can actually do this in Maya too. So you can use a texture to emit particles from. And this is just a reversed version of that. So I play the animation. Oh, you didn't get to see who it was in the end. Let's see. I think I'm on real time. I got to go back to play every frame. Okay, that's better. Can you tell who it is? Guess? Yeah? Oh no, Bob Marley. Yeah.
That's cool though.
So as I was looking at that animation, the effect that you had was nice, but I thought it might be interesting to try and do it in 3D. So let me just show you how this works. I'm just going to open up a new scene. Actually, I'm just going to set the project. Just have to find this shader. Where do you think I put it? I wonder. My tests. Lecture set. Okay. So I'll just create a plane here. And I'm going to put a new material on here. I'll just put a Lambert. You don't have to put a new material for this to work, but this will just allow us to see where what the texture is like. So here's our Lambert material. I'm just going to map a checkerboard onto this. So you've seen before that we can emit particles from an object, but we can also use a texture on an object to drive where the particles are emitted from. So if I select this, I'm just going to delete its history, use transformations, and I will go to Particles, Emit from Object. Turn up the rate per second. No speed. So just hit Create. So now if I play the animation, so particles rain down, and if we just turn off just tell them to ignore gravity, then they should just be born all over the surface, equally in the white or black areas. If we look at the emitter for this, though, so my emitter is called Surf2. If we look down here at the bottom, there's this thing called texture emission attributes. And so you can have your particles pick up colors from the surfaces. If there's a texture piped in here. So if you want the colors to be black and white, you can put the particles to be black and white depending on where they're born. You can put the same shader in here. But you can also use it for texture rate. So you can say where it's white, emit no particles, where it's black, emit particles. So turn on emit texture rate and say emit from dark. And then we have to pipe that same texture here into the texture rate. So I'm just going to open up my Hypershade because it's the easiest place to find it. If it'll open. Okay, it doesn't want to open. Let's try that again. Alright. Okay, so how can I find this? I can find it in the outliner. My Hypershade is not cooperating. So find that. So there's my checker. So I'm going to just copy this tab so I can have the surface emitter tab open even if I select something else. And I'll just drag my checker pattern onto the texture rate. Normally I would just grab it in the hypershade. So let's see if this works. So now you can see they're only being emitted from the dark spots here. So if you have a black and white image that you wanted to fill in, so I had the Bob Marley one, so let's try that again. Let's put a new, just going to break the connection here and map a file. Now it doesn't always work the first time for some reason. Well, just because it's Maya, I guess. But so just because I put that, and I just chose this one because I was looking for a harsh fall off between black and white. Courtesy of spraypaintstencils.com. So even though it's on here, if I play the animation, it'll still respect the checkerboard, right? Because that's the one that's piped into the texture rate. So you can still see the checkerboard is forming there. So instead, we have to change that so that file texture goes in there. So let me just find it here. There it is. So there's my file. So I'll just drag that, middle mouse, drag that over, and let's see if it works this time. Yeah, it seems to be. So it's just, they're only being born in the black parts of the material. I'm just going to turn off self-collide, and I'll fill it with way more pieces so we can. And I'm going to make them smaller. And I'll make them black, I guess, just so it looks like it's recreating the image. Or I'll just leave them one color blue so we can see them. And I'll increase the rate just so they fill up faster. So it'd be 1,000 particles a second. So because they're not self-colliding, they're not pushing each other out of the black spaces here. Okay, so let's say we got it to a point like this where we're happy with it. You can select those particles and set their initial state. So under Fields and Solvers, initial state set for selected. And then we can just turn off our emitter. Okay, so just turn that emitter to 0, right? So now we just start with the particles like this. And so if we want them to form into this shape, then essentially we want to push them away and then reverse the animation. Okay, so let's do that. So we'll select those particles, and I'll just do something like a turbulence field. In the last one, I used the curved flow field that we used for blood flow before to have them come in from a direction, but that's kind of a pain to set up right now, so I'll just use a turbulence field in a sphere shape. So if I just play this, let's see what happens. Okay, so they all go into random orientation. So if I want to reverse this animation, I have to cache it first. So caching it means turning off dynamics and just recording the position of each particle over time. So I have the particles selected, and I'll go to ncache. I'm going to create a new. Actually, I'm going to save this before I do that. do save as, and then I will end cache, create new cache. This is an object, it's not a fluid, so only two options. And this is at frame 140, so let's cache for 200 frames. So that's pretty good. And end particle shape 1, yeah, I should have named it, but I didn't. One file per frame, start and end, evaluate every one frame. Okay. So let's do that, and it will run through the animation up to frame 200. Okay, so it finished at frame 200. Now I'm going to limit my playback to frame 200 so it doesn't go over, because if it goes over those 200 frames, then it has to start dynamically solving it again. But I just want to turn off my dynamic solving. So in my particle shape, I can find it here. So the end particle shape up at the top here, I can turn off enable. So it won't solve anymore. I can even go into nucleus and turn that off too. So I know now any animation on these particles is just from the cache. And I know that also because I can scrub back and forth. Okay, so let's hide this plane. Let's see the animation. So, but we want it to happen in the reverse, right? We want them to be generally moving around like this and then to come into this shape. So there are a couple ways we can look at doing this. If I select the particles, you'll see that there's a thing called the end particle shape cache, or whatever I named the particle. And I can just click on reverse here, and it should play it in reverse. So now they come together to form the face. I'm going to actually give myself a few more frames so we can see it. Sitting there. I've got the dynamics turned off, so it's not going to solve anymore after this. There you go. The other way to look at this, and I know I've worked with some of you using the tracks editor on a couple of things, but if we go into animation editors in the tracks editor, you'll see that the cache, any cache that you haven't seen will show up here. And you can extend the cache or compress it. You can reverse it here. You can chop it up. You can split it and stop it and hold on a frame. So if I want to shorten the cache, I can just grab this, and this should compress it, have all the same animation. It'll just have to drop positions. So its old value is from 1 to 200. Now it's playing in a time from 1 to 100. Still in reverse because I turned that on. And by frame 100, it's already in that position. You can have it hold on a frame. Actually, I can't remember how to do this. I hold down. Yeah, if you hold down Shift in the top right corner, you can have it hold on the last frame. Although this gets a little wonky because we have reversed the animation. I'd like to hold on the first frame, but I can't actually figure out how to do that. You can also tell it to cycle too. Cycle. Can't remember cycle. Just look this up. Well, thanks for taking me to the right page, Maya. No. Tax editor. Yeah, so this will give you an idea of what you can do here, but the tracks editor just allows you to take these animations that have been turned into clips in some way, either by caching or baking or making animation clips, and you can change the quality of them. So you can cycle clips here. So starts and ends, and if you shift drag the lower corner hotspots. That's what it was. So hold down Shift. Yeah, so now you can see it says C. So it will cycle twice. Again, because it's in reverse, I'm not sure what it's going to do exactly. Yeah, so it just plays it through again. I'm not sure if there's a way to oscillate between, so it goes back and forth. There probably is a way to do that, but so for an animation like that where you want particles to come together, or if you have like a shape, an arrangement of particles or objects, even if you solve them dynamically, you can just cache out the animation and play it in reverse to do something like that. Okay, is that clear? Any questions? Okay, it's 1 o'clock, so why don't we take a break for lunch? I'll just go for half an hour and grab a quick bite, and then you guys can do what you want, but I'll come back in here at 1:30 just to help out with folks, because I have to leave right at 4 today, because I have to hop on the shuttle, unfortunately. Okay, great.